Your textbook has over 30 chapters, and if you try to read every single page from cover to cover before exam day, you are going to burn out. Here is the secret the syllabus doesn't tell you. JAMB is lazy. Yes, they recycle concepts. I'm not saying they recycle questions, not like that. They recycle concepts, and I've analyzed over the past 10 years of past questions, and I realized that most of the questions come from just 10 topics. If you master these 10 chemistry topics, you are not just passing, you are entering the exam hall with 90 plus marks in your pocket. Today, I'm giving you the list. Grab your pen, grab your notebook. Let's take them down. At number one, we have the undisputed king, organic chemistry. If you skip organic chemistry, that is organic chemistry 1 and 2, just forget about scoring high because it carries the highest weight in the exam, usually 5 to 10 questions. Don't just read the intro. You need to know one, IUPAC naming. They are surely going to ask this. Two, isomerism, your geometric and your structural isomerism. Number three, we have the families, that's your homologous series, the alkanes, the alkenes, the alkynes, the alkanols, and the alkanoic acids, including your alkanoids. Number four, we have saponification and esterification. Master this and you've covered 15% of your exam. Next, we have the math of chemistry. Yes, this is where most students run away, and this is where you can beat them in order to have an edge. And number two, on our second topic, we have stoichiometry and mole concepts. You need to be able to balance chemical equations, calculate mass and volume of products of chemical reactions. If you can't calculate molar mass, empirical formula, and all these things under the mole concept, then you are in trouble. And number three, we have electrochemistry containing your redox reactions and your electrolysis. Under redox reaction, you need to know your oxidizing agents, your reducing agents, and balancing of redox reaction. Then for electrolysis, you need to know your Faraday's laws of electrolysis, how to solve questions under them. You also need to know what is discharged at the anode and at the cathode during electrolysis of some chemical compounds. Finally, you also need to know the electrochemical series, right? From your potassium, your calcium, right? Then you also need to know the order of their reaction, okay? Which elements can substitute the other element in a particular compound. Normally, elements above for metals above another metal in the electrochemical series can displace that metal in a particular compound. So in order for you to know this, you can go and learn the mnemonic for electrochemical series. And number four, we have your gas laws, your Boyle's law, Charles' law, Graham's law of diffusion, Gay-Lussac's law of combining volume, and other gas laws. The trick here is mostly you converting from Celsius to degree Kelvin. Okay, you also need to know your ideal gas equation. And number five, we have the periodic table and periodicity. You don't have to master or cram the whole periodic table, how it's arranged. No. What you need to know is that you need to know the trends. What happens to ionization energy as you move across the period and down the group? What happens to atomic radius as you move across the period and down the group? What is the effect of nuclear charge and the screening effect of electrons? What happens to electronegativity and electropositivity? You need to understand these trends because this is mostly what they test under periodic table. Number six, we have chemical bonding, ionic versus covalent versus coordinate covalent bonds, and specifically intermolecular forces like your hydrogen bond, your van der Waals forces. You also need to know the compounds that have these bonds. Also, you need to know your shapes of molecules, right? Your s orbital, their shape, p orbitals, their shape, and their bond angles. At number seven, we have chemical equilibrium and rates of chemical reaction. You have your Le Chatelier's principle. This is a question that you must see. Okay, if pressure is increased, where does the equilibrium position shift to? If you increase the volume, the number of molecules, where does the equilibrium position shift to? You need to understand this logic. Don't cram it. You need to understand it. Also, you need to know the factors that affect the rate of your chemical reactions, like your temperature, your catalyst, your surface area, and your pressure. Number 8, we have your acid, bases, and salt. This is a very big question. Okay, you need to know your definition of acid according to different persons. You need to know your types of salts, right? Your acidic, your basic, your double salts, your complex salts. Okay. You also need to know calculations under crystallization, your pure and impure salts. Also, you need to know pH calculations and then neutralization reactions, right? When you carry out this one is basically tested in WAEC and then it's usually tested in JAMB also, but not as complex as it is tested in WAEC. You need to know your calculations under neutralization, the amount of acids that will neutralize a certain amount of base and vice versa. Also, they can change the number of moles and things like that. So you need this acid, base, and salt is an underrated topic, but it has a lot of things inside for you to master. And number 9, we have your separation techniques. This is usually the first question you're even going to see. Okay, you have crystallization, fractional distillation, chromatography. You need to know the process that separates a particular mixture. Okay, what they usually test is the physical properties that is being used to separate those mixtures. So you need to know which techniques separate which mixture. Okay, this is like a bonus question. And finally, we have nuclear chemistry. Okay, alpha, beta, and gamma decay, calculations of half-lives, nuclear fission and nuclear fusion. These questions are cheap questions, but don't let the concept of the word nuclear to scare you. And calculations under them are just simple maths questions, calculations, right? Now, here is a bonus topic you also need to master. Let's say topics. Okay, you need to master your non-metals and their compounds, and then metals and their compounds. This is like if you count all the non-metals and then the metals that they are tested, it's like more than 10 topics, but it's massive. But if you understand these particular topics, right, non-metals and their compounds and metals and their compounds, then you have a very broad knowledge of inorganic chemistry already. Listen, I'm not saying you should not read the other topics. No, that's not what I'm saying. I'm saying if you have a limited time or you are feeling overwhelmed, then these 10 topics plus the bonus topic will be your lifeline that can save you. If you master them, then you have a guaranteed 80 plus marks already. Here's my advice. Now, take this list, then you go to your past questions, right? Then you tick those particular topics I've just mentioned. Then you go solve all the questions on a particular topic. Let's say you start with organic chemistry now. You solve all the questions under organic chemistry from 2010 to 2025. Then you move to stoichiometry and more concepts like that. Do not study year by year. No, study topic by topic. That is how you build mastery. That's how you become unstoppable. If you found this breakdown helpful, hit that like button so that it will enable the video to reach more students who are struggling. And don't forget to subscribe. If you want me to do the same breakdown for physics and biology and other subjects, let me know in the comments which subject you want me to do this breakdown for next. Go and crush it.